one chapter is the graphing part and one chapter is going to be the algebraic. This chapter is the graphing part, but there will be some factoring that you will need to have in here. So let's start talking about this. If you've never learned this stuff before, from my understanding, so this stuff is completely new to you. The only thing that's going to be the same is the factoring part. Okay, so let's talk about what it means to be a rational function. It's kind of in the name, ratio. So we're going to have a ratio of two polynomials. Okay, so ratio, rational, kind of makes sense. So ratio of the two polynomials. That just means that there's like a division sign. You don't necessarily have to have a division sign. So some examples are something like this. 1 over x could be in an example. So you can see it's a ratio or a fraction of some sort if you want to think of a fraction instead of a ratio. It could be something as simple as like 3x squared. Okay, yeah, it doesn't look like a fraction, but technically it's over 1. And then this one could be something like x plus 5 over x plus 1. So those are some pretty good examples of what it means to be a rational function. There is a question on your final and on your test for this chapter to ask you, which one would not be irrational or which ones would be rational. There are two situations where it would not be rational, and that's when we have some kind of radical. For example, like 2x divided by radical 3 or radical x, I should say. If you have this radical, then you know that it's not irrational because it's actually called a radical function, which we will get into next chapter, next semester. Another example is when there's a variable in the exponent. So what does that mean? Like something like 3 to the x power. The power has the variable in it. So if you were asked, which one's not rational, okay, if you see something with an x in the exponent or a radical, then that's going to be the ones you would circle here. Yeah, we will get into both of those types of functions next chapter. You guys will really like the exponential chapter because there's a lot of relatable stuff in there. Like the half-life formula that you guys did in physical science, it's coming back next chapter because that's going to be the exponential growth and decay. Okay, so it says excluded values. Values of the function's domain where it is undefined. So sometimes when you guys put it in your calculator, the graph, it'll say undefined. Like you go to your table, the y value will say like UND. That just means undefined. It doesn't exist there. Okay, and that happens when the denominator is equal to 0 because that doesn't work. If you go in your calculator right now and do like 3x or just 3 divided by 0, it's going to say error because it doesn't work. You can't divide anything by 0. It's not possible. Okay, it's actually pretty easy once you get into it. Again, this is all different, so just bear with me. All new to you. Find the excluded values for each function. So we're going to set the denominator equal to 0. So I'm going to set this piece here equal to 0. So I have 2x equals 0. Well, what would I do to both sides? Divide by 2. So I just get x is equal to 0, and that's my answer. But now we're talking about excluded values. So it's not going to equal 0. It's not going to equal 0. Okay, so I'm just going to put a slash there. So that means that all values in the world will work, but 0. And if you go on your graphing calculator, which we're not going to do right now, if you were to type that into your graphing calculator, you would see that there's like this undefined thing happening at 0. I am going to pass out 2 highlighters because I think it's important because it is a new topic. Okay, 1, 2, 1, 2. I got you another one. Oh, sorry. Ready, Alex? 1, 2. You got them back there. 1. Oh, you got 2 now? Okay, you got 2? Okay, cool. Okay, so if it helps you to highlight one of them, so that you know that's where it came from. On this next one, it's that simple. It's that easy when you're trying to find the excluded values. This chapter, I will say, the goal is to just do one big problem. And we'll get to that later on. But we're going to take each day and break it down. So today we're talking about excluded values. Tomorrow we'll talk about this piece of a graph, and then we'll talk about the next piece of the graph. So it's like we're breaking up a big problem into small pieces today. Well, the whole chapter. So now, you just want to look at the denominator. So I'm just going to look at the x plus 1 and I'm going to look at the x minus 1. Those are two separate excluded values. That means in your graph, there's going to be something happening at this place and at the blue place. So the yellow one, I'm just going to show you what it means, and eventually you're going to get faster at it. You can set it equal to 0 and solve, so x plus 1 equals 0. And then here, I have x minus 1 equals 0. Well, in black, what would I have to do to both sides? Yeah, minus 1. So x cannot be negative 1, and we're done there. Because we're just solving. Now, what about the blue one? You add 1. So x cannot be a positive 1, and we're done. So those are the excluded values. If you go to your graphing calculator, which we'll see actually on the next page, there's something happening at negative 1 and 1 on your graph, and it's going to be undefined. Now, in your head, you probably could have figured that out. We've done this before. Opposite sign, opposite sign. Okay, we have done that. It's just now in a different format. Questions on that? Okay, so we just did those two. I want you to do E and F, so the ones right below it, because they're the same things, and I want to see how you're doing with it. Okay, so E and F, I want you to give it a go and see how you would do on that. So try E and try F.
Would it be a 1x?
So technically it's 1x, yes. Very good. So like again, you could, if you are someone that doesn't have to set them both equal to 0 and solve, then go for it. Because these ones you could just like know in your head that x can't be 2. Because when I do 2 minus 2, you would get 0. Okay, so if you know that, you don't have to show all of that work if you're at that level. If you're not, write it all out. If you are done and done only, you can look up and see how you did. If you did not finish, keep going. I'll give you another 30 seconds. I feel like a lot of you are still working. That's okay. Pretty straightforward today, kind of just easier, just getting your feet wet today on rational functions. Okay.
Blast off.
I know, is that the projector or is that the, I think that's a projector. It's that? Okay. Do you have questions on E or F and like how I got any of it? Okay, like I said, if you're that person, there are some of you in here that I feel like you could skip this step and go right to the end and then do that. There's no sense, I'm that person that does not like when you show extra work if you don't have to. If you know how to do it, then just do it. Okay, I'm not going to require you to show that kind of work when it's that simple. Okay, let's look at these next ones though. Let's go back to C. This one we can't figure that out right away because we need a factor first. We're just going to factor the denominator for now. Don't worry about the top piece yet. We'll get to the top piece tomorrow. So let's just factor out the denominator. So I'm going to put a little star here. Factor first. Okay, so we got to factor this guy out. So I'm going to rewrite it. F of x is equal to that top piece. Nothing has changed. We haven't done anything. We're just rewriting. But I'm going to take this piece in pink, and I'm going to factor it. Let's see if you remember. This is called difference of two squares. What's the square root of x squared? X. What's the square root of 9? 3. Does anyone remember how we would write that when we factor? Because we have done this. We have x and we have 3. There's two groups. I'll show you. X plus 3. There we go. And x minus 3. Very good. Okay, so the reason why we had a factor is so that we can find our excluded values. If we don't have our excluded, or if it's not factored, there's no way to find the excluded values. So now I have two of them. Here we go. Here's one of them in yellow, and here's one of them in blue. So x can't be -3, and what else can't it be? +3. So as you see there, if you're at that level, which I think almost all of you are, or all of you, you could probably just tell me it's the opposite sign. If you want to write it all out, you can. I'm going to show you now by skipping a step, I can just go right to the end. And that's it for that one. Remember that equal sign with a slash just means like it can't be. Every number in the world but -3 and 3 will work for this problem. Okay, because we just did that one, I want you to do the one right underneath it to get like some repetition here. So try G, because it's exactly the same thing that we just did. And I'll leave mine up there so you can see it. Something just happened in my thing. I'll leave mine up there to kind of, you can use that as a guide. Just try to mimic that same exact problem for G. Put the first step up there to check your answers if you're there yet. If you're there, I didn't finish it, but if you're done with the factoring part, you can at least see in pink if you got it correct, and then keep going with it. Why am I out of breath? Like, I don't know. Too much sitting around past couple days. Going with it. Some of you are still working, and that's great. Okay, so I wrote it out for you. A lot of you probably went from here to here, and that's good, but if you had to write this step, it's okay too. I'm just showing you that this part was not necessary if you knew it right away. But if you set it equal to 0 and solved, hey, go for it. Like, I do not care at all which way you do. Just depends on where you are and if you like to have like this repetitive pattern. Do you have any questions for G? This next one, I will recommend that you do write it out because of this reason. We're going to do D together, and then you'll do the one below it. Pretty easy. There's no factoring to be done, but we do have to set this bottom piece equal to 0 and solve. Now, some of you might know right away that it's -6/5 just because you know your math skills, but I'm going to prove to you why that is what I just said. So 5x plus 6 is equal to 0. We're setting it equal to 0, and we're going to solve. What would I do first to both sides? Good. Subtract 6 to both sides, and I get 5x equals -6. Then what would I do? Divide by 5. Very good. So in pink, I'm going to divide by 5. Divide by 5. Let's get rid of it right there. And my final answer is it cannot be -6/5 because that's now an excluded value. Again, the reason why that works, if you plug in -6/5, you're going to get 0 in the bottom, and it'll be undefined. It won't work. It doesn't exist. So I want you to try the one below it. Try H and make sure that you get it. And if you're struggling, let me know. I'll come and explain because that one's a little bit different. I'll leave this up as a guide for you. You can leave it in fraction form. Most of the time they won't divide out, and then they will be a fraction like -6/5. If you get the decimal, that's fine. It's just fraction's fine. I wouldn't try to do too much work. If you're done, you can check and see how you did. Careful with your signs. Like in my head, to kind of show you how my brain works, I could have gone from here all the way to here, because I know I'm going to subtract 7, divide by 3. Subtract 7, divide by 3. So if you know mentally how to do these problems, I'm all for it. A lot of people, 90% of people, have to write all of it out, and that is okay. But I'm trying to show you how to do that mental math in your head. I just know in my head, I'll subtract 7, divide by 3. Subtract 7, divide by 3, and that's why I get -7 divided by 3. Okay, cool. So that's kind of like dipping your feet into like what this whole entire unit's going to be like. We're still going to keep going and kind of talk about what it means on the graph, and then we'll be done here. Okay, we probably only have about 10 more minutes left of the notes. So we just did all this work, and now the question is, what does it mean? Yes, there's something on the graph that's happening at the value that you just found out. So the very first example here, write the function in factored form, find the excluded values, and then state the domain. So the only new thing that we're doing is this domain part, and I'm explaining to you like what's going on with what you're doing. So on the top, there's nothing to factor. So I'm just going to rewrite that one on top. Is there a number that goes into both -3x and -3? Is there a number that goes into both of those? We're just looking at the bottom. Good, a 3. And whenever there's a negative out in front, you want to pull it out with it. So remember how we did this. I'm going to divide each little piece by that GCF. If you like to write that all out, you can. So I'm going to write that -3 on the bottom. And then whatever's left over is going to be in black. This is kind of going slow with our factoring skills. This cancels. I'm left with x. And then what's -3 divided by -3? +1. Very good. Careful with the 0. It's very common, though. So I get x minus 1. Oh, not -1, +1. You were right, Anna. Okay? Because I divided each piece. Do you have questions on where that came from? That was just factoring. You want to look at a lot of these problems as like, just look at the top, just look at the bottom. Don't look at it as a whole. Okay, now let's kind of talk about what this means. Okay, we'll kind of do what we did in the first page. I'm going to highlight this piece. What makes the bottom piece equal to 0? I'm not going to highlight the 3 because there's no x involved here, so it really doesn't matter. The only thing that matters is where the x is. So what makes x plus 1 equal to 0? What makes x plus 1 equal to 0? What would I do to both sides? Subtract 1. And that's why -1 is my answer there. All from the first page, nothing new. All I did was I subtracted 1, I got here. Now let me explain what this means graphically. Okay, so I'll give you a second to write things down so that you can pay attention to like what you're actually doing. Because that's the biggest thing. You find this -1, you're like, cool, excluded value is -1, but do you know what that means? And I'll explain it in a second. Okay, so what that means, I'm going to take that highlighter, the same exact highlighter. I'm going to highlight this piece, okay, because they all correlate with each other. X plus 1 in the factored form tells me that I have an excluded value at -1. Now let's take a look at the graph. Here's the graph. Do you see at -1 there's this dotted line? I'm going to highlight that piece too. It doesn't exist at -1. You can see these graphs. They're like going towards this dotted line and then shooting up, but they're never touching it because they don't exist there. Like there's no function that exists. Same thing here. If you look on this side, it gets really close, but technically will never touch that -1 because it's undefined there. And like I said, if you look at your table of values on your graphing calculator, it will tell you it doesn't exist there. So that's what you just figured out, that -1, which we'll talk about what that line means tomorrow more specifically, but to kind of give you a visual and kind of like getting your feet wet and to figure out what's going on the rest of the week here. So that does affect our domain, okay? So if we go left to right, I always start at -infinity, and I'm going to stop wherever wherever my excluded values are. So I'm going to stop at -1. You see how it literally like is a wall, and like the graphs do not touch the wall. That means that it doesn't exist there. So I have negative infinity, because that's where I always start, negative infinity, and I'm stopping here at -1. It gets weird at first, but it's actually pretty easy once you get used to it. Wherever you stop is now where you start. So I'm going to start back up at -1, and I always end at positive infinity, and I'm done. Again, that's coming from your excluded values. Whatever your excluded values are, that's your domain. And you can see here on the graph, so that you can understand it, you start at negative infinity, you stop at this wall at -1. And then you keep going till you get to positive infinity. There's no other like stops in your graph. There's no breaks in your graph. You can kind of see that. Like left to right, I have a graph, it stops at this wall. And then the wall on. Okay, that's your domain. Pretty easy once you get used to it. We got to keep practicing it. Do you have any questions on the first one? Taking it slow today. Are you sure? Because it is a little different. Okay. We're used to this graph. We've seen it before. It looks like a quadratic. This is from chapter 4, that little U shape. If you remember me talking like way back when, which I'm sure you didn't, I told you that there would be this thing called a hole. And now we're at that time. We're at that level where we can talk about these holes in the graph. Okay? And remember when we had like these brackets, don't write this down, versus a parenthesis. That's what I was talking about. Sometimes you will have a hole where you can't include it. And that's why it was important that you understood that brackets include it and parentheses do not. So factored form. I kind of already factored a little bit for you. This is just like the one on the first page. I'm going to rewrite the parts that don't really matter because they can't factor. So I have the x and the x minus 2 don't factor. You can't do anything with those two pieces. But that piece right here can be factored into our difference of 2 squares. What's the square root of x squared?
X.
And what's the square root of 4? 2. So in green here, I have x plus 2 and x minus 2. And we're done. So I'm only going to give you guys the easy factoring ones. I'm not going to try to like throw this difficult factoring at you on top of this. Okay, so if you feel comfortable with this one, which I think you will, you'll be okay. Now, the excluded values is the next question. It's what makes the bottom equal to 0. So I have to talk about just the bottom. Don't really care about the top. Okay, so what makes x minus 2 equal to 0? What can't x be? Positive 2. Very good. Now, again, you could have just gone right from here to here and not written this piece in. It's totally up to you. But you always set the denominator equal to 0. Now, you don't even have to look at the graph to know what your domain is. Because whatever the excluded value is, that's where you're breaking it up. So I'm going to show you kind of like how I would do this. I wouldn't even look at the graph. I put the graph there to kind of show you. So the domain always starts at negative infinity. Always. You're never going to not start there. Then you're going to go to, I'm going to highlight this piece. I'm going to highlight this next piece. To 2, and then 2 to infinity. And I'm going to highlight those pieces because it's never going to be different. Okay, if you look, all of those pieces are correlated. This tells me the excluded value, which means like it's not going to exist there. And then because it doesn't exist there, we have to talk about that in the domain. So that's why that 2 is represented here. And if you go back to the other problem, it's the same thing. That -1 was represented there as well. So if you look, it kind of all goes together. And now let me explain that on the graph. So now we have this thing called a hole. And if you look there, it's at 2. Okay, this piece, that hole, that's what you just figured out. That excluded value of 2 is at your hole. Here's 2. It's at the hole. Okay? And tomorrow, or actually in 2 days, we'll actually figure out what the actual hole is. I just wanted you kind of see it. Okay, let's look at these two. So the only other factoring one that you're going to have to know how to do is those basic factoring ones. Let's see if you remember this. I'm going to go way back. F of x is equal, I'm just going to write the top out because it really doesn't matter. It's already factored for us, which I do that a lot for a lot of these ones. So all of these pieces in black are already factored. The only piece, I'm going to use my other color highlighter here, is that piece I have to factor. I have to figure out, what's going on. Whenever there are 3, we have to do that mod table. So I'm going to kind of go off to the side here. What multiplies to -3 and adds to -2? Well, the only 2 things that multiply to 3 are 1 and 3. We just need to figure out our signs. I'll zoom in here. Good. I have a +1 and a -3. If you remember doing that. These are going to always be the easy ones. I'm never going to throw a hard one at you. So they're going to be ones that you can go right to the end once you find these numbers. Do you have questions on how I got this? Or Jamie got it, actually. Because -3 + 1 gets me -2. If you multiply them, you get -3. That's going way back. Now in blue, I'm just going to replace that blue piece I highlighted with x + 1 and x - 3. And we're done with that part. The only reason why we have to factor is to figure out what our excluded values are. If you don't, then there's no way to actually figure it out without looking at your graph. Now on the test, obviously, if you get stuck and you don't remember how to factor, go backwards. Look at your graph right now. I can see that there's something happening at -1 and +3. And remember when we did factors, it was always the opposite. That was from last chapter. I can kind of go more into that when we know more information. We'll kind of go into the shortcut methods later in the week. So then there's going to be how many excluded values here? 1, 2, 3. What's going to happen? How many excluded values am I going to have? 2. Because there are 2 x's on the bottom. So that's how I know that. I know there will be 2 excluded values because there are 2 x's on the bottom. So in yellow, what can't x be?
-1.
Good. And then in blue, what can't x be? 3. Okay, and if you wanted to rewrite that out for yourself, if you're this person that needs to write out x + 1 = 0, please do that. I'm just kind of going to show you the shortcut method at this point when they're easy like that. Okay, so like this, you could have gone right to the end, but if you needed these steps, then write them in for yourselves. Okay, the domain is really easy again. You have to just go left to right on the number line. So I'm actually going to write that in. Left to right. On the number line, would -1 come before 3 or would 3 come before -1? Good. So we're going to go in the order on the number line. So here we go. -infinity to -1. -1 to the next excluded value. And I'll show you with some highlighters here. It always just goes in order. And you'll get used to it after a while. So I'm going to use the 3. And now 3, and we always end to positive. And after you're done writing, I'm going to kind of explain some things to you. If you take a look, you're going to use this excluded value twice like we always do. Where you stop is where you start. And then the other one, same thing. Where I stop is where I start. You're going to use it twice. That's where it's coming from. And if you look on the graph, I'm going to highlight one more time. This piece right here in blue is the 3. This piece right here is the -1. You can see my graph goes on forever and then stops at -1. Keeps going, stops at 3, then keeps going. Okay, there's like these breaks in the graph that's happening here. Do you have any questions on that? Okay. This one's an easier factoring one, nothing too difficult. The top is already factored for you, so f of x is equal to 3x - 7, x + 2, nothing's changing. The bottom. What can I factor out of the bottom piece of this graph? What can be factored? There's no numbers because 3 and 7 are both prime.
X.
Good, x. So I'm going to take out this x, and what's left is just 3x minus 7. Okay, if you want to make a note for yourself, we divided this piece by x and this piece by x, and that's how we got 3x minus 7. Okay, how many excluded values will I have because there's this many x's in the bottom? How many? 2. There will be 2 excluded values because I have 2 x's. I'm going to highlight them both. This one in yellow and this one in blue. There are 2 x's, so I have to include both of them. You set them both equal to 0, so x is equal to 0. Oh, that was pretty easy. I mean, there's nothing else you can do there. You set them both equal to 0. This one you might have to write out. 3x minus 7 is equal to 0. What do I do to both sides first? Add 7. So I get 3x equals 7. And then what's my final answer? So what do I do to both sides? Good. Divide by 3. So I get 7 over 3. So x can't be this fraction here. Now I'm going to go to my graph so you can see where they're both at. And they're both different. So let's highlight this yellow one. Sorry, whoops, something just happened. This yellow piece is 0. So at 0, I have this excluded value. So this right here in yellow is what you're talking about. You found this like line looking thing. However, in blue, it's this whole. 7/3 is like 2 point something. That's why it's like right here. So that's the 2 pieces you found that are excluded. They both mean something. One's called something and the other one's called a whole. And we're going to get into that in a second here. And then we're going to be done. So we're going to define like what that line represents and what that little blue hole represents. And then we're done. Just going to get a definition here. Okay. The domain. Okay, that's going to be pretty easy. Let me just do it for you here. Negative infinity. Which one comes first, 0 or 7/3? 0. You can even look at your graph to help you out if you need to. So you see how like I go negative infinity is where I start. I got my zeros. Then I'm going to add in my 7/3. 7/3. We always end at positive. If you want to highlight, you can see that that's coming from there. And that's coming from there. Okay, this chapter is, because we're like running out of time and with the snow day, we got to make sure, I know that these are going to be longer notes, but I think after the amount of review that we're going to do and how slow we're going to take this chapter, you guys are going to be rock stars and do really well on the test. This test always has really good results because it's multiple choice and the stuff on there is not too difficult once you get used to it. Okay, so these are actually called, so when we analyze all of these holes in the graph, the excluded values, they're called something, they're called discontinuities. So discontinuities. It takes me a while to spell. So if you ever hear someone say, what are the discontinuities? That just means what are the excluded values? Where am I going to have like these undefined values on the graph? There are 2 separate things. We kind of already talked about it. There's called a removable, which is a hole. I'm going to highlight the whole piece because you'll hear me say whole the most. And then infinite, which is a vertical. It's called an asymptote. It's hard to say. It's weird. If you guys took science, I got it confused last year when I was teaching isotopes because I'm so used to working with asymptotes. Okay, it's just a weird little name that it was given. So if you look at these here, I'm going to show you this one because it's a really good example. This yellow piece, that's a vertical asymptote. It's a line. If you notice it, goes all the way up and down. The hole is obviously the blue piece, the hole. Now, if you look at the hole, let's kind of like observe the function for a second. Do you see how this hole in blue, do you see how these things are going to cancel? I have 3x minus 7 on top, and I have 3x minus 7 on the bottom. Do you see how they're the same thing and they would cancel? That creates a hole in your graph. If it cancels like that, you've now created a hole. This x right here doesn't cancel with anything. And that's why it's called a vertical asymptote. So those are just two definitions to kind of get familiar with. Okay, and you can see the line, the yellow piece is called a vertical asymptote. And the hole, it actually looks like a hole in your graph. Okay, so here, this piece, I just wanted to make sure that you guys knew that it cancels. So if there's a factor on the top and the bottom that's the same, then you have this thing called a hole. Here, if it's remaining, there's nothing left, like it's just remaining at the bottom, any remaining excluded values, it does not cancel with something on the top. So that's kind of like getting your feet wet. Definitions, not too hard of stuff, it's just new. And the homework's really easy. It's the stuff that we just did. Just take your time, and it's only one page, only 8 questions. But I kind of want to take one more second and make sure that you understand the difference between a hole and a vertical asymptote. So do you see here for this one? This doesn't cancel with either of them. This doesn't cancel with either of them. And that's why they were both vertical asymptotes. They were both lines. Okay? Let's look at this other one. Here, this canceled. Boom, it creates a hole. The moment you cancel something out, it's a hole, and that's why you have a hole at 2 and not a line. And then the last one that we did here, do you see there's nothing to cancel x plus 1 on the top? You need exactly x plus 1, and that's why we have a line. So that's a vertical, I always put VA, that's a vertical asymptote versus a hole. So hopefully that kind of makes sense. If it cancels, hole. If it doesn't, vertical asymptote. We're going to practice that a lot more this week, so don't, like, it's just get your feet wet a little bit here. Very easy homework assignment, only 8 questions. You should actually be able to finish in the 10 minutes that you have left. Okay, all new, so if you have questions, just ask. Use your notes as a guide. I try to give you, like, as much information on here as I could, but it looks exactly like your notes. Kind of gave you, repetitive ones. For 1 through 3, you just circle your answer. So yes or no, is it rational or not rational? You can just circle it. And then if it's not rational, I want you to explain why. Like for number 2, I'll do number 2 with you on the homework. Number 2, kind of go off to the side here. Number 2 is not rational, so I would circle the not one because of why. I'm going to kind of like highlight this piece right here. It's not rational because we cannot have radicals. And I would accept that explanation. Okay, it's not rational because we cannot have the radical sign. Or you can actually write out radical if you want. I would accept this too. Cannot have radicals. Either one's fine. Or. So you would circle not rational because it has a radical. So that's all I'm looking for. And on your notes, in the very first thing we did, I gave you the explanation. Radical, variable, and the exponent, that kind of thing. Okay, the key's up there. Check your answers. Took me a minute to do. So it'll probably take you 10 or 5, depending on how fast you are. Okay. Good first day back.